All right, and today in 3.3 we're going to be graphing systems of linear inequalities eventually. Before we get going with that though, we're going to review how to graph singular inequalities in the coordinate plane. So we're going to graph this inequality, y is greater than 3x minus 1. And the first thing you're going to do is graph the boundary line, y equals 3x minus 1. And to graph that, one thing we know about this line is that the y-intercept is the point 0, negative 1. And the slope is 3. So from this point, we're going to go up 3 and over 1. And continually going up 3 and over 1. Now, before we graph this line, we have to determine whether it's going to be a solid line or a dashed line. And what tells you whether it's a solid line or a dashed line or not is that inequality itself. Okay, like over there. Now, in example A, we have just greater than, which means that the boundary line itself is not included on part of the graph. So it would be kind of like an open circle, except it's a line. So to signify that with a line, it's going to be a dashed line. And that is the boundary line. Now, next, we are going to determine which side of that line we're going to shade, either this direction or that direction. And just to avoid any confusion, what I do is I pick a point that is not on that line. And the easiest point to pick and to substitute in is always 0, 0, as long as a line does not go through that point. If it went through the point 0, 0, then we would have to choose a point on other than 0, 0. But since this line does not go through 0, 0, I'm going to pick the point 0, 0, and I'm going to plug it into this inequality. The y-coordinate is 0, and the x-coordinate is 0. Now, in this case, I just check to see if that point makes it true or not. If it makes it true, then I'm going to shade the side of the line that that point is on. If it makes it false, I am going to shade the other side of the line. So in this case, the point 0, 0, and if I simplify the right side, 3 times 0 is 0, minus 1 is negative 1. And is 0 greater than negative 1? Yes. Since 0, 0 makes that true, I am going to shade this side of that line. And that's what it looks like. Now, in the second example, again, the first thing I'm going to do is graph the line y equals negative 2x plus 1. And taking what I know, the y-intercept is 1. Slope is negative 2, so I'm going to go down 2 and over 1. And then I'm going to determine whether this should be a solid line or a dashed line. So I look at the inequality, since it is greater than or equal to. That means the line is part of the graph, so I am going to make this line a solid line. And then finally, I'm going to determine what side of that line to shade. That line does not go through the point 0, 0. So I am going to choose the point 0, 0 and see if it makes that inequality true. Is 0 greater than or equal to negative 2 times 0 plus 1? And again, if it makes it true, I'm going to shade this side of the line, the side that that point is on. If it makes it false, I'm going to shade the opposite side of the line from that point. So, simplifying that right side, negative 2 times 0 is 0, plus 1 is 1. Is 0 greater than or equal to 1? The answer is no. So then I'm going to shade the opposite side of that line. And that was just a quick review of how to graph singular inequalities. In the next video, we are going to see how to graph systems of inequalities.